In this video, we're going to talk about quadratic functions and their properties. The most popular form of a quadratic function is standard form. So it's written something like this, where you have f of x or y is equal to ax squared plus bx plus c, where a, b, and c are real numbers, and a cannot equal 0, because if it did, it would zero out the x squared part, and that's what makes it a quadratic, so make sure your a is not 0. Otherwise, you're working with a linear function. Also, the domain of quadratic functions is all real numbers. And some other things. There's a lot of different vocabulary and points of interest on a quadratic function, but some are. This vertex point, which is either the lowest or the highest point, depending on what your a value is. And your a value, if it's greater than 0, so if it's positive, that means that your quadratic is going to open up or makes like this smiley face. And if your a is a negative value or less than 0, it's going to open down. And another thing to note here is your axis of symmetry. It exists in all quadratics, and that is a vertical line that has some x equals a number, and that number is always the x coordinate of your vertex. And as you can tell by this image, it is a vertical line that splits your quadratic in half. So the left-hand side mirrors the right-hand side and vice versa. Now, the great thing about the vertex and the axis of symmetry is that we can derive those points and that line from your original standard form equation. So remember the a, b, and c values? Your vertex, or your axis of symmetry, the x value is going to be negative b over 2a. So you negate this b value, multiply a by 2, and there you go. And then whatever that number ends up being, if you plug it back into the function, like you would if you were looking for the y value of any point, you plug that back in, and then you got your x comma y value of your vertex. And again, if you have an a value that is positive, your vertex is going to be a minimum, because that quadratic is going to open up and go up from that point, and the opposite is true if your a value is negative. That's going to be a maximum, and your quadratic function is going to open downward. Now let's apply that information to this example. So without graphing, locate the vertex axis of symmetry of the parabola defined by this function here, and does it open up or down? So we need to identify our a, b, and c values. So most parabolas and quadratic functions are written in order, meaning that the highest power goes first, the second highest power second, etc. But always check to see if your function is written in a different order, because that's going to change your a, b, and c values. All right, so this is written in order, thankfully. So a is negative 3, b is 6, and c is 1. So the first thing I'm going to do is plug it into our negative b over 2a to find the axis of symmetry as well as the x value of my vertex. So I plug in my values and I negate the 6, so negative 6 over 2 times negative 3, that's negative 6 over negative 6, which is 1. So my axis of symmetry is going to be a vertical line at x is equal to 1. So now I'm going to plug in 1 into my function to figure out what the y value of my vertex is. So when I plug 1 in to this function, I get out 4, so that means that my vertex is 1, 4. And I like to write a capital V in front of that coordinate pair, just so that it indicates that this is the vertex that I'm talking about. And last thing that we need to figure out in this example is, does this function open up or down? And it's going to open down. I didn't need to do any of this writing to figure that out. I just need to identify a. It's a negative 3, so therefore it's going to open down. So the parabola will look something like that. Now let's talk about the x-intercepts of a quadratic function. So before we even talk about this, there's something that you need to know in order to understand what I'm about to tell you. And that is the discriminant, and that's b squared minus 4ac. And that comes from the quadratic formula, which you memorized at one point in your life. You may not know it as well anymore. But the thing under the radical in the quadratic formula, the b squared minus 4ac, that's what we call the discriminant. And that, depending on the output, that tells us the kinds of intercepts that we have of a quadratic function. So, for example, if your discriminant, the thing under the radical, b squared minus 4ac, is greater than 0, so if it's positive, then that means that we have two distinct x-intercepts that crosses the x-axis in two different places. That's this situation, right? Two different x-intercepts, Pretty standard. Second, if your discriminant equals 0, then you have one x-intercept and it touches and bounces off the x-axis at its vertex. So that's this situation. It's pretty rare because it's a very specific discriminant, but it does exist. And lastly, if your discriminant is less than 0, so if it's negative, right, what happens when you have a negative number under a radical? It doesn't exist. So it doesn't have any real roots. It still has a vertex. It could be above or below the x-axis. It just will never touch the x-axis. So it has no real roots or x-intercepts. Let's work on this example. So it's got many, many parts to it, but I believe in us. So let's take this quadratic, x squared minus 6x plus 9, and let's figure out all these things. First, let's determine if it opens up or down. Well, let's find my a value that's in front of the x squared. If it has no number there, y'all know it means 1. It's positive. So this function is going to open up. And now let's find the vertex, axis of symmetry, and our intercepts. So I'm going to find the vertex, the x value of the vertex first, right? Negative b over 2a. Let's do that. All right, I got a little carried away here. But I plugged in negative b over 2a, and that gives me 3. So x equals 3 is going to be my axis of symmetry. And I plugged in 3 into my function to find the y value of my vertex, and that gives me 3, 0, which when I plot it is right here, which is interesting. So we know that that's going to be the vertex, and it's going to open up, so it's going to create the discriminant is equal to 0 situation. So we have one real x-intercept. So we actually happen to find the vertex and the x-intercept at the same time. Fun. Last thing that I'm going to do in that first bit is find the y-intercept. And we do that by setting x equal to 0. So when I plug in 0 into my function, I get 9. So my y-intercept is 0, 9. There's no other y-intercept. So I plot that, and I happen to know that if this vertex creates this axis of symmetry, it's going to map 0, 9, 3 over from the vertex and 9 up, so that's going to be at 6, 9. Please forgive this awful curve. I tried to make it straight. It didn't happen. Just let's pretend. So those are my 3 key points that I would put on this graph. So I took the book's graph, which is so much better looking than the one that I tried to make, because we still have part B and C to do, and that is to determine the domain and range, and then to determine where f is increasing and where it's decreasing. So domain, easy peasy. That's going to be all real numbers. So using interval notation, negative infinity to infinity, and then range of a quadratic is, or this one in particular, is going to be 0 inclusive, and it's go to infinity. So your range on any quadratic, whether it opens up or down, is going to include the y value of the vertex. So it'll be on the left-hand side if it opens up, and it will be on the right-hand side if it opens down. And then part C, where is this increasing, where is it decreasing? So remember, we read the graph from left to right. So coming in from the left, it's going to decrease until x is equal to 3. So that's this situation, starting at negative infinity to 3. And remember, increasing and decreasing will always have parentheses and interval notation. It will never include the point where it changes, and it will never include infinity and negative infinity. You know that. And then, of course, it's increasing from 3 to infinity, not including either of those. Another thing you can do with the vertex is transform the form of your quadratic equation from standard form, that ax squared plus bx plus c, into vertex form. So the proof is here below, and it's also in our textbook if you care to read it. I will not read it to you right now. But vertex form is known as this formula right here. So we have an a value, which is the same as in standard form. So if this a is 2, that a is going to be 2, for example. And so in parentheses, we have x minus h. So x is the same x as in your f of x. That's an input. We keep it x. And h is the x value of your vertex. So we call the vertex h comma k. So that is x minus h all squared. And then at the very end, we have plus k. So k is the y value of your vertex. So let's take that information and see if we can apply it to this example. So sometimes you're not actually given the equation of a parabola. It happens. And you're only given certain information to determine the equation of said parabola. In this example, we are given a vertex and another point, which happens to be a y-intercept. So our vertex is 1, -5, and our y-intercept is 0, -3. So with the graph, we can tell that our a value is going to be positive because this function opens up. And let's say you didn't have the graph, you could plot these things on Desmos or on a piece of paper and figure out this thing has to open up, because if this is the vertex and the y-intercept is above that in terms of the y-axis, then that means that this thing has to open up. And this is going to be a minimum value. So whenever I'm given a vertex and another point, I use the vertex form of a quadratic, which is this function here. And using the 2 points, I have 4 pieces of information. So the vertex, remember, is h, k. So 1 is going to be my h, and -5 is going to be my k. And my other point, whether or not it's an intercept or some other random point, that's going to give me my x and y value. So the x here is 0. And my y, or f of x, which is the same as y, is my -3. So that's going to go there. So I'm going to plug all that in, and you'll notice that the only variable left to find is a. So let's solve for a. So plugging in all my values accordingly, I solve for a, and that gives me 2. So all I need to do is plug back in my 2 for a, and then I keep my x and my f of x because that's like my x and y. Those things are inputs and outputs. We leave them alone. So that's going to be 2 times quantity x minus 1 squared, because h always stays, and then -5, just like h, k always stays. And if you wanted to FOIL that out and expand that and get that back into standard form, for whatever reason, this also suffices. It's the same function. So that's the equation of that parabola. So I want to do one last example where you might be asked to find a maximum or minimum value of a quadratic function. So that should signal to you, hey, find the vertex and find out if this thing opens up or down. So let's say that we have this quadratic function in standard form, x squared minus 4x minus 5. So to me, I say, ooh, a is 1. That's positive. Great. That's going to open up. So that means that my vertex is going to be a minimum value. Let's find it. So remember, identify a, b, and c. Negative b is going to be -4, positive 4. 2 times a, which is 2 times 1, over 2. 4 over 2 is 2. So x equals 2 will give you your axis of symmetry and the x value of your vertex. So when I plug in 2, I'm going to find the y value of my vertex, and that gives me -9. So my vertex is 2, -9. And technically, when you ask for a minimum or maximum value, you are looking for the y value of the vertex. And so the minimum value of this example is going to be -9. And it's minimum, remember, because the a value is positive, so from the vertex at 2, -9, that thing is going to open up. So the minimum range or y value is going to be where that vertex starts on the y-axis, which is why it's -9. All right, to summarize, there are a lot of things you can do with a quadratic function. You've got some options here. I'm not going to read this whole thing to you. Take a moment, read it, or find it in the book, screenshot it if you want it, or just flat out ignore it. Whatever you want to do. All right, that's going to do it for this video. Thank you for watching.